A measurement displayed on a microscope screen is not automatically proof that an incoming part conforms. The result depends on the optical configuration, calibration reference, software settings, operator choices, and the way image edges are interpreted. Change any of those conditions, and the reliability of the measurement may change with them. That makes the buying decision more specific than simply choosing a camera with distance, angle, circle, or rectangle tools. The real question is whether the proposed workflow can support the decision being made. Visual review may be enough for obvious damage, missing features, gross placement issues, labeling, or conditions that need further investigation. A controlled image measurement can provide a repeatable reference when the setup and calibration are fixed. But when acceptance requires defined uncertainty, traceability, or capability beyond the validated camera process, the result must move to formal metrology or an approved escalation route. The measurement chain begins with the optics. Pixels become a physical dimension only after calibration for a particular configuration. Lens, adapter, magnification, working distance, camera settings, focus, and illumination can all influence the relationship between the image and the inspected feature. A sharp image may make an edge easier to see, but sharpness alone does not establish a valid scale. Lighting and material condition matter as well. Reflections, low contrast, curved surfaces, shallow depth of field, and lighting direction can make an edge ambiguous. Incoming inspection should therefore use a repeatable lighting arrangement, a documented focus method, and controlled board or part placement. Validation should include representative finishes and component geometries, not only a clean calibration reference. For gates, provide a practical control structure. First, confirm the configuration. Record the camera, lens, adapter where used, magnification or zoom state, working distance, illumination, and display or capture path. If multiple setups are approved, each requires its own calibration evidence and scope of use. Second, calibrate against a known reference appropriate to the size range and field of view. Define who performs the check, how often it is repeated, what happens after a configuration change, and which result is acceptable. Retaining an image of the reference, when practical, connects the physical standard to the setup used by the operator. Third, check repeatability before routine use. Repeat representative measurements across captures and, where the task is operator-sensitive, across qualified users. The purpose is to determine whether the process produces stable evidence for its intended decision. Material variation between captures or operators is a signal to tighten the procedure or escalate to another method. Fourth, retain the decision context. The record should link the image and result to the sample or lot, inspected feature, operator, camera configuration, calibration status, and disposition. Without that connection, an image may become an illustration rather than auditable evidence. 5 weighted controls help prioritize review: calibration control, result traceability, optical consistency, operator procedure, and storage discipline. Calibration and traceability deserve the strongest emphasis because they connect the visible image to a defensible decision. A measurement-capable model such as the Fantru B36 8MP4K digital microscope camera may be evaluated for its on-screen measurement functions and available connectivity. Those published functions do not establish lens-specific scale, calibration interval, tolerance suitability, or repeatability for a particular inspection task. Buyers should confirm the software description, mounting and lens information, supported operating conditions, sample evaluation process, and technical support route. In routine use, identify the part, lot, and feature. Select the approved setup, confirm calibration, prepare the image, capture and record the result. Compare it with the acceptance rule, and retain the evidence. Borderline, ambiguous, out of scope, or near-limit results should follow one of 2 escalation routes. Restore the controlled setup when the problem is procedural. Use approved metrology or specialist review when the feature, tolerance, material, or geometry exceeds the camera workflow's established capability. The value of built-in measurement is not that it eliminates metrology. It is that, when controlled properly, it makes useful visual evidence faster, repeatable, and easier to govern, while keeping its boundaries clear.